All right, number 3, we're going to solve this rational expression. Now on this one, we got to be careful. 9 or negative 9 would not work if you set the denominator not equal to 0. So we got to keep that in mind. If we solve this and negative 9 turns out to be a potential solution. This time the denominator is the same. So there's a couple different ways we can do it, but I'll just try to keep it consistently doing the same thing because it works every single time. So one thing you could do is you could just move this over, like subtract the 2 from 5 and have 1 and multiply, but I'm going to keep it in the same setup. I'm going to multiply the denominator, which is p plus 9. Since that's the same, I only need to do it once to everything. So I'm going to multiply everything by p plus 9 times the whole expression. Okay, so when I multiply p plus 9 times this expression, it cancels out, leaves me with a 2. When I multiply p plus 9 times a 3, it gets distributed 3 times p, positive 3p, 3 times 9, positive 27. And then equals, and when I multiply the p plus 9 times this last term, it cancels out, leaving me with 5. At this point, we're going to combine the 2 and 27 on the same side, so that will give us 3p plus 29 equals 5. We're going to subtract 29, move it over to isolate the variable p. That's going to leave us with 3p equal, this will be a negative 24 when you subtract the 29, and then you divide by 3, and you get p equals negative 8. Of course, you want to plug it in and check to make sure it works out, but the only thing that won't work is a negative 9, and this is not negative 9, so negative 8 will be our solution. All right, number 4, we're going to solve this rational expression. We have 7 divided by p squared, and then 8 divided by p equals a negative 1. So common denominator, this is p squared, and this is just a single p. P times p will give us p squared, so if I just multiply by the larger p squared, that will cancel out everything. So I'm going to, or at least all the denominators. So I'm going to multiply p squared times the whole expression. Now in this example, I want to be careful to note that p cannot be equal to 0. If 0 comes to be a solution, we will get rid of it. So when I multiply p squared times the first expression, it cancels out, leaving me with a 7. When I multiply p squared times the middle term, one of the p's cancels with the 1 on the bottom, and that will leave me with a minus 8p. And then when we multiply p squared times the negative 1, we get a negative p squared. So this is a quadratic. I'm going to set it up equal to 0 and solve. So I'm going to move everything to the left. I'm going to add this p and put it in the correct order. So this is going to give me p squared minus 8p plus 7 equals 0. I want to see if it factors. It looks like it may. So 1 times 7 will give us 7. Factors of 7 are 1 and 7, and we would want to add to get 8. And 1 plus 7 does in fact add to give us 8. So we're going to split up the p squared, a p here and a p here, and then in the back the 1 and 7, the factors that we found. Going left to right, the first sign going left to right tells me the bigger number. So out of the 1 and 7, the 7 being bigger is going to be negative. The second sign, positive, tells me same. If this second sign was negative, it means they're different. Second sign being in the original expression, or the expression that we're factoring. So since this is positive, that tells me both of these are going to be negative, which makes sense. I need it to be a -8, -1, and -7 would give us a -8. All right, once we have it factored, we're going to set both linear factors equal to 0 and solve for p. So we'll get p equals 1 and p equals 7. Neither of those answers cause a issue, because it would be 0 would be the only issue. And so we have two solutions, 1 and 7.